Hi all. So thank you for coming. Uh, Ramble of my experience with taking over the reins of this software in the bottom right here, bottom left rather. Yeah, I'll go into details. It's called Osdag. Uh, I'll go into details as I continue. So basically, uh, this is the flow of today's talk. Basically, I'll go into the background of one myself and two this entire project. Uh, go into the situation that we had, um, then go through the iterations that we have been going through, and then the next steps. And yeah, that will be it. So let's start with me. I am Ajinkya. I'm a mechanical engineer by training, but but kind of now a developer like almost everyone else. Um, Although I still keep my work towards more simulation, scientific computing sides. I've been a contributor to the 3D parametric modeling software FreeCAD since around 2016, and coincidentally, that was around the time when I moved from Python to C++. So I was working on Python until that time, and then the software I was working on tended to be like C++ stuff. So yeah, and mainly my experience is towards development rather than the maintenance side. So that is why I kind of joined this team to get uh, that kind of experience, basically. So I'm working as part of this team with uh, Professor Siddhartha Ghosh leading, and apart from me, we have Ajmal, who is a PhD scholar, and Parth, who is a fellow staff basically at I, yeah, and a whole bunch of interns basically, uh, and yeah, I'll go into details further. So yeah, so let's me start with what is Osdag. So Osdag stands for Open Steel Design and Graphics. It's basically uh, made with the aim to build confidence in steel structure design in India, and to that extent, it aims to follow this one particular uh, standard, which is considered the Bible for steel construction in India, basically. I'll just show you the. I'll just play the demo. Uh, okay. So it's a desktop application. You can see that there are multiple uh, individual components that can be tested uh, or rather, yeah, let's say tested for whether they are safe for the load they are going to bear. So in this case, it's going to be a tension member. So it's going to be in a state of tension, and so for that, it will say we tell what load we are going to apply, and then it will just tell you what's the best among the available sections for it. It will also tell like how it's expected to fail, or rather which failure we are preventing. I guess that's the best way to put it. And it will tell how to place the bolts, a whole bunch of complex things. Um, if you are not a civil engineer, this might not be that exciting for you, but yeah, it is still very complex and pretty important stuff based on decades, possibly centuries of wisdom. Um, so in that sense, it is complex for in terms of the engineering aspect, but the application itself is relatively simple. It just you give the inputs, it will check against values, and it will give the outputs. And yeah, it can also provide very detailed reports of what all conditions have been satisfied, what all conditions have failed, So yeah, all that it is going to loop through. So I'll close this. Okay. So let's go into and Osdag is part of the FOSSI team at IIT Bombay. Uh, we are among like a dozen other softwares that are promoted, and some of them are built in house as well, like Osdag and like eSIM here. We are funded by the Ministry of Education through the NME ICT scheme. I'm not sure what it's called, but yeah. Um, so apart from this, a whole bunch of things that we do. We so I invite you to take a look when after this talk. So yeah, I'll go into the history again now. So Osdag itself started somewhere around 2015 to 2016. The first commit that I can see on GitHub is August of 2016, but there are, uh, I mean, I don't myself exactly know when it when it when it was founded, but that is around the time. So a bunch of things went on. By 2021, I think COVID hit possibly and for that because of that, uh, the development was kind of in a idle hibernation state, and so and we resumed around September of 2024, so last year. Um, as I showed, we are about 4 people uh, permanently, and then a whole bunch of interns who do kind of most of the work, basically. Uh, and so we were looking for solutions that would that would be satisfactory for this kind of people. So it's like the staff is going to be mainly civil engineering, possibly a few mechanical engineering students like graduates like me, and the interns may be computer science and others, but still undergrads, so they haven't really cut their teeth as such. So simple solutions. That was kind of the goal. So we started with this situation, uh, looking at 2021 code in 2024 and trying to run Osdag. Now that was our first hurdle because now we are not able to install half of the like almost anything. Um, there were some workarounds to do to get things working in Windows and Ubuntu as well. It's like trying to maintain with some very old repositories, um, which would not work out if we one are asking someone to install it, a general user to install it, and two also for development. Um, so that was the first issue. Second major issue was that we have to ask the user to run Python osdag main page.py to actually run the program. So um, we'd rather want either just a command osdag and it runs and it runs the program, or like a desktop icon. So that's another. Then another major issue in the internal side was basically there was one folder which was being used for like 3 different purposes. One was to store the databases and images that relate to basically the sections, the bolts, the kinds of elements that we support, and then it also stored temporary files and preferences, which should be like 3 different places. One should be in configuration, one should be in temp files, another should just stay in the installation. So that was kind of our starting point, and from there we wanted to get to a place where I'd go to have where we would have uh, a conda install Osdag, and that way uh, it's all in our it's all installed basically. That was the goal. So for the uninitiated, although it is highly unlikely it would be the case given that this is PyCon, uh, conda is a repository and packaging system basically for not just Python but a whole bunch of um, basically any software kind of, and it like uh, VNV, it will also support environments with various versions of dependencies and other things. So this was already in use, but it had gotten stale basically. We were keeping the old tar files, and based on just those we were running. Um, Also, as a side note, like conda was kind of restrict. Almost everything could be done just by pip because this was a very Python heavy application. But Python OCC itself, which is the geometry kernel, that was like that has a lot of C++ stuff. So it was best to so it was only available through conda. So basically what we do is it is all through uh, we install Python OCC through conda, and it can, and like pip can just believe that everything is accessed through Python. So yeah, uh, there were three major issues uh, in this step. So one was relative imports. Uh, in that I'll just get into those. Second is entry points, and third was accessing the basically images and databases that I mentioned earlier. Them through any folder basically. So I'll start with this one. So when when we install and we are expecting to run through from any folder, uh, Python may not always know where like these where these packages are. So if we keep it this way, in the worst case scenario, it won't tell you, or maybe it is the best case scenario because the other option is it. Okay, yeah, yes. So the other option is basically it would create all these when we run pip install, it would create all these files, which is just duplicates of these. And now there is some rogue utils and common package on the top level. So yeah, so basically we just moved to uh, a, what is it? Relative imports, which is also like a relatively new phenomenon. I don't think I knew about it in 2016. So yeah, that was so with that we're able to run everything else, but now we can't run basically all we can't just run Python Osdag main page.py. So we have to run it as a module, which is not a big drawback, but it is still a new thing to know. Okay. So the second one is after. Oh wow. Oh wow, I'm turning way out of time. Okay. Um, so the second one was like entry points. Basically, if you want to convert your Python program into like a standalone application, pip, like I think setup tools and conda offer these things called entry points, where you just specify what uh, what the what command to run, and uh, where what method in the what method in what module to run when that command is called, and it just basically does that for you. Um, and apart from that, import lib was a new development sometime, which seemed to be specified since I think Python 3.9 or 10, and that is that offers for a more standardized way of accessing images. Uh, so this way, we were able to run it just from any folder. Be able to tell, okay, get this PNG from this particular place. Yeah. So, and apart from that, there were some dependency issues on. These are minor issues, but once you note that it is hard, there are in possibly dozens or hundreds of files, and you can't exactly tell um, which ones, and not always you can tell. So like the top one was easily the easiest one. You just run a grep and you know where everything is. You can also pipe it to sed to change it. Python OCC basically, this was probably a one-line fix, but this one was the biggest hurdle because like there was we want they wanted some windows to uh, when we wanted to size set the size of a window. Uh, the window would be called probably anything. You just so there were like so many methods where we had passed float and we should have converted them to int. So that took a bunch of iterations. Um, yeah. So that's basically it. Um, so now we were able to run through conda maybe like 75% of times. So the other 25% of the time, what would happen is we'd install half the dependencies, and then we would try to install Osdag, and it would just say it would just cause some conflict. It was so conda was so conda is a good method to store things basically, but it is the conda the tool is kind of we found it not too satisfactory when it comes to resolving multiple dependencies and all that. So slight workaround was one to either install everything in the first place or try to install through Mamba. But Mamba itself becomes a different another thing because you have to install Mamba through Conda separately and then run Mamba, and that is yeah, that works hard. Okay, so apart from that, these are a few newer situations, newer developments that are done by interns. So I'm not confident about telling. I'm not as confident about these myself because I haven't worked on them as much. But this is how it works. So I skipped over a slide where it said we had a three-step installer. So that was fixed here, which is like now we use another layer of abstraction over conda called pixi, and using that we were able to basically package it into a single step. So and yeah, pixi itself, it's relatively a new tool, but um, and it helps in a sense that if you just run pixi run Osdag. You don't have to activate any environment or anything, it will just run. Um, but from some experience with FreeCAD, uh, it does seem to change quite frequently. So that's why I'm not 100% on promoting it at the point, but it is definitely something to keep an eye on. So yeah, that is the, yeah. So that once that is done, there are some more future plans. One, to add a robust plugin system, basically, so that we can modify, so that we can add custom modules to the to Osdag, uh, make any standard changes, add, and as well as connect to some sister projects that we are working on. Yeah. So, and apart from that, there is like Qt 5 is end of life. So we are moving Qt uh, from PyQt 5 to PySide 6. This will offer a bunch of advantages as such as like apart from just a 5 to 6, it's also LGPL. So in case we need to add uh, proprietary extensions, that would be a possibility, as well as a new UI in the making. So, and apart from that, like web version, which will which will basically be like uh, we have some workshops basically. So in that we can ask them to, instead of installing Osdag, just try it out through web, and in the future possibly a software as a service solution as well. So these things are in the making. Of course, all this will also need some refactoring. So that will offer a better maintainability. We'll also be able to tell how something has gone wrong, uh, and also we can use the same core calculations for both the desktop and web versions, which was not done as such yet. Um, yeah, and the last thing is like add a con add it add Osdag to Conda Forge. So currently you have to install it through the Osdag channel. The Conda Forge channel would be um, step up, possibly. It's like a more standard way to store things. And a whole bunch of other features to complete modules, update update standards, add a command line interface, etc. Also documentation. So that's about it from my end. So if you're interested, we invite you to get involved. You can contact us through this page. Uh, a whole bunch of expectations from for students, faculty members, professionals, whatever step you are. And yeah, that's about it.